Hello all, I'm Mustapha the SOLIU. So today I'll be presenting on the lesson learned from a riser design assignment titled Riser Concept for Disconnectable Turret Mod FPSOs in Harsh Environments. So the presentation focuses on how different riser concepts can be applied to FPSO units in challenging regions such as the North Sea and the Gulf of Guinea, because these areas present some of the harshest offshore conditions in the world with strong waves, currents, and wind forces. So the selection of the risers system in this condition is not just a matter of engineering, but one of safety, economics, and long-term field success. So during the course of my presentation, these are the objectives I will cover. First is to provide a background on FPSO system and to explain why riser design is a critical part of offshore oil and gas development. The second one is to assess different riser concepts, so which include the steel catenary risers, steel lazy waves, and hybrid risers. So the third is to discuss current technology and gaps and industry innovations such as the composite materials, digital twins, and updated standard and codes. So the fourth is to recommend the best riser concept for the disconnectable turret FPSOs. And lastly is to relate the findings to industrial practice and professional rules. The background studies. So FPSO are vital for deep water oil and gas development, as we know that FPSO is a floating production, storage, and offloading unit, and these are one of the most important technologies in deep water oil and gas because they allow operators to produce hydrocarbon from remote fields without requiring expensive field fixed platforms. Even fixed platform might not be suitable for some of the harsh environments in higher deep water. So instead of using a fixed platform, so oil and gas can be processed and stored on board and then offloaded into a shuttle tanker for exportation. So North Sea and Gulf of Guinea present harsh environments. In deep water environments such as these two identified region, the conditions are extremely demanding because of the high waves, strong currents, and winter storms cause the FPSO to move significantly. So these are the challenges with these are the vessel motion, fatigue, touchdown zone, and the flow assurance. So because of the motion of the FPSO, this motion are transferred into the risers, which are the critical conduit that connect the subsea equipment with the topside facilities. So at the seabed, the touchdown zone, which is known as the TDZ, is especially vulnerable to fatigue. So wear and VIV, vortex induced vibration. So at the topside, the hang-off point also experience cycling loading. The riser concept options. So there are three main categories of riser concept for FPSOs. So the first one is the steel catenary risers or SCR. So this is the simple, they are simple, cost effective, and fatigue, but they are fatigue prone. They are vulnerable to fatigue. So they're essentially simple, as I said, because of the simple curve shape that connect directly between the seabed and the FPSO. But it is cheap and easy to install and was widely used in early deepwater projects. However, in harsh environments, it is prone to fatigue at both the hang-off and the touchdown zone, so making it less suitable for the FPSO in harsh environments. The second option is the steel lazy wave risers. So the steel lazy wave risers or SLWR and its flexible counterparts. This riser use buoyancy model to create an inverted U shape which absorbs the FPSO motions and reduce fatigue stresses. So the configuration has proven to be highly effective in decoupling the vessel dynamic and is increasingly the industry standard for turret mod FPSOs. Uh, the third category, which is the hybrid riser towers, so HRT. This system uses a vertical riser tower anchored to the seabed, so which connect to the FPSO via a flexible jumpers like a gooseneck. It provides excellent motion decoupling and fatigue performance, but it comes with a high cost and complex installation procedure. That means, considering the economic aspect, the HRT is very, very expensive. So each of these risers concept identified has its trade-offs, and the best choice depends on the project condition, such as water depth. So we have to consider the technical and the economic aspect, like the water depth, the methosion environment, and also the field architecture. So the lesson learned from the case studies. So looking at the real world projects help us understand how this concept work in practice. For example, in the stones, in the stone FPSO in the Gulf of Mexico, Shell successfully deployed still lazy wave riser with a disconnectable turret. This project demonstrated that the SLWR can handle ultra wave risers, can handle ultra deep water depths of nearly 3,000 meters. So also in West Africa, like the Giraso and Greater Plutonio in Angola. So they deployed hybrid riser towers. This system provides effective in decoupling FPSO motion and reducing the fatigue at the touchdown zone. However, their installation was complex, and the cost was considerably higher compared to alternative risers. So the technological gaps. The industry is not standing still, as we all know. Several new technologies and standards are reshaping riser design. So one key area is composite risers, such as thermoplastic composite pipe. This material, their importance is that they are of lightweight, corrosion resistant, and fatigue resistance as well. Also, digital twins, particularly the use of digital twins and advanced monitoring. So they allow operators to monitor, to predict the fatigue and manage integrity using real-time data. So the tools like Deep VIV VivoNet have been proposed for advanced photos in these vibration predictions. So on the last one, which is the standard. So there are a lot of standards like API 17J 5th edition in 2024 and DMVST F27. So this standard provide a frameworks for flexible risers and system level analysis. So this document solidify abi codify best practice for fatigue VIV and harsh environment operations. So market trends also shows a growing subsea riser market expected to reach over $7.5 billion US by 2024. So the recommended concepts based on the identified riser so far. So based on the analysis, the most suitable solution for disconnectable turret FPSO in harsh environment is a submerged buoy turret system combined with lazy wave flexible risers. So this setup works as follows. The riser and mooring are connected to a submerged buoy. So during a storm, when there is a heavy wave or emergency, the FPSO is disconnected and sail away until it reaches a safe place. So while the buoy submerged at a safe depth, keeping the riser intact. When condition improves, the FPSO can reconnect back. So that's the reason why this is the best options. So the relevance to the industry. So the lesson learned from this report apply directly to industry rules. For subsea engineers, the challenge is in designing riser that can handle fatigue, voltage induced vibration, and complex subsea interactions. So for installation contractors, which are responsible for executing tow-out buoy installation and ensuring weather windows for safety deployment. For integrity engineers, which manage the monitoring system using tools like fiber optics and digital twins to track fatigue, armor corrosion, and touchdown zone ways. So their role ensures safe long-term operations. And finally, the operators and project managers, they make decisions on concept selection, balancing capital expenditure, so operational risk and regulatory compliances. So on the last but not the least, the second to the last slide, so which is the lesson for professional practice. The key lesson from professional practice as follows. First is that there is no universal riser concept. So it depends. Every project require context-specific solution that balance cost, risk, and environment. So second is the motion decoupling is critical for survivability in harsh seas. Lazy wave and hybrid system demonstrate this most effectively. The third one is the life cycle thinking must guide design. A riser concept is not only about installation but also about how it will perform and be monitored for more than 20 years, or even like 20 or more than 20 years. So finally, is the collaboration is essential, as we all know, among the operators, contractors, and the OEMs is key. So with the rise of digital technologies and advanced materials, this collaboration is becoming even more critical for successful offshore operation. So that is that for this presentation. Thank you for listening.